Good morning, students. In continuation with the video lectures on motion in a plane, that is chapter 4, this is the last video which I am giving, and in this video we will discuss about the numericals on circular motion. In the previous video we had discussed about only one topic we had discussed in the previous video, and that is about the centripetal acceleration AC is equal to V square upon R. We had derived that relation by the Trendle law of vector addition. We had derived that derivation, and now in today's video we are discussing about the numericals based on the same topic, that is centripetal acceleration. So the first numerical in front of you, students, look at the numerical. A cyclist is riding with a speed of 27 km per hour. There is a cyclist and he is riding with the speed of 27 km per hour. First of all, we have to convert it into meter per second. As he approaches a circular turn on the road of radius 80 meter, this radius is 80 meter. He applies a brake and reduces his speed at constant rate 0 meter per second square. So he applies a brake means this is the acceleration retardation applies. If the cyclist applies the brake, then the speed is going to be reduced. And as the speed is going to be reduced, it means that the acceleration is acting opposite to the speed. And if acceleration is opposite to the speed, then it is the case of retardation or negative acceleration. Then what is the value of and direction of the net acceleration? So look at here, students. This is the tangential acceleration on applying the brake, and there, since it is the circular track, there is a centripetal acceleration also. We have to find the centripetal acceleration, and then the resultant of both acceleration will give the resultant acceleration. The resultant of the angle is 90 degree, so A is equal to resultant acceleration is equal to AC square plus AT, tangential acceleration plus centripetal acceleration, and then we find the value of alpha. This alpha will give the direction. So we will make the detailed diagram while solving it. So look at the question, and if you had understood the numerical, then try to solve it by yourself. I am also giving the solution of this question. So look at the solution of this numerical. Now dear students, the solution is here. V is given, that is equal to 27 km per hour. So our first and foremost task is to convert it into meter per second. 27 into 1000 upon 60 into 60 meter per second. 6 cancel out. Then 3 9 ja 27, 3 2 ja 6, 3 2 ja 2 5 ja 10, 3 3 ja 9, and 3 2 ja 6. 15 upon 2, and it is equal to 7.5 meter per second. This is the velocity, and radius it is already given in the question, 80 meter. Now we have to find out the value of centripetal acceleration. Centripetal acceleration, that is AC, and this is equal to V square upon R, that is 7.5 square upon 80, and it is equal to 0.7 meter per second square. On calculation you will get meter per second 7.7 0.7 meter per second square. Now look at the diagram, students. This is the center of the circular track and this is point P, where the cyclist is moving with velocity v. This is the direction of centripetal acceleration AC, and when he applies the brake, this is the tangential acceleration EA. This is velocity v. Now the resultant of these two accelerations gives net acceleration. The resultant, since the angle is 90 degree, this angle is 90 degree, means the angle between tangential acceleration and centripetal acceleration is 90 degree. So from here we can calculate the, now it is given, we can calculate the, by parallelogram law of vector addition, we can calculate the net acceleration. Now it is given in the question the value of tangential acceleration AT, that is 0.5 meter per second square, 0.5 meter per second square, and angle between both the acceleration, it is equal to 90. Angle between both the acceleration is 90. Now we will calculate the value of centripetal acceleration. Value of centripetal acceleration. The value of net acceleration, resultant acceleration, magnitude of resultant acceleration, and it is given by AR, and which is equal to AC square upon AT, AC square under root AC square plus AT square by the help of parallelogram law of vector addition, and it is equal to 0.7 square plus 0.5 square, 0.5 square, and which is equal to 0.86 meter per second square, which is equal to, this is the, on solving this, on squaring this and taking the square root, we will get the resultant acceleration, that is 0.86 meter per second square. Now dear students, we will find the value alpha. We will find this value alpha, which is the resultant acceleration max with the tangential acceleration. Let A, and that is net acceleration or resultant acceleration, max angle beta with tangential acceleration AT, then tan beta is equal to perpendicular upon base, that is AC upon AT, and AC is what? AC is 0.7 upon 0.5, so tan beta is equal to 7 upon 5, or beta is equal to tan inverse 7 upon 5. So this is the magnitude of resultant acceleration and this beta is the direction of resultant acceleration with the tangential acceleration, that is it. So this is about this question. Now we will discuss the next question. Now dear students, look at the question in front of you. Here it is given that two cars of masses m1 and m2 are moving in circles. Two cars are moving in circles. This is first circle, this is second circle. One has radius r1 and other has radius r2 respectively. Here for radius r1 the car m1 is moving, for radius r2 the car m2 is moving. Their speeds are such that they complete the circle in the same time. Both are completing the circle in the same time. The ratio of their centripetal acceleration. What is the ratio of their centripetal acceleration? You have to choose it from it. So we have to find the solution of this, and for this we have to use the formula for centripetal acceleration, and after that we can solve this question. Look at here, students. Solution to this question. As we know that centripetal acceleration is equal to v square upon r. So for first body of mass m1, for first body of mass m1, what is the value of centripetal acceleration? The value of centripetal acceleration can be AC1 for the first body, and it is equal to V1 square upon R1. For second body of mass M2, AC2 is equal to V2 square upon R2. Now according to question, both masses are completing the circle in same time. Means both are completing the circle in the same time. Means time for completing the circle, so distance upon speed. So if t1 is the time for, then it can be given as 2 pi r1 upon v1. If t1 is the time for the mass m1, and if t2 is the mass for, then it can be given as 2 pi r2 upon v2. I think you had understood that. Suppose this is circle and radius r1, then for completing the circle the distance traveled by the mass m1 is 2 pi r1 with velocity v1. So time t1 is equal to 2 pi r1 upon v1, and suppose this is radius r2 second circle, and time t2 is equal to 2 pi r2 upon v2. But according to question, both the times are same. So we can say that t1 is equal to t2. For t1 is equal to t2. So 2 pi r1 upon v1 is equal to 2 pi r2 upon v2, and from here pi to 2 pi cancel out, and v1 upon v2 is equal to r1 upon r2. we had found the relation V1 upon V2 is equal to R1 upon R2. Now ratio AC1 is to AC2, AC1 is to AC2, and it can be given as V1 square upon R1 divided by V2 square upon R2, and it can be written as AC1 is to AC2, it is equal to V1 square upon R1 into R2 upon V2 square, and from here we can write it as V1 square upon V2 square into R2 upon R1. Now V1 upon V2, it is given R1 square upon R2 square into R2 upon R1. R1 to R1 cancel, R2 to R2 cancel, and it is equal to R1 upon R2. R1 upon R2. So the ratio becomes AC1 is to AC2 equal to R1 is to R2. This is the correct answer, AC1. That is C option is correct. C option is correct. AC1 is to AC2 is equal to R1 is to R2. Now next question. Now students, look at the next question. An aircraft executes horizontal loop. This type of loop, this is the horizontal loop. So an aircraft executes horizontal loop of radius 1 kilometer. Horizontal loop, this is horizontal loop, and the radius is 1 kilometer with a steady speed of 900 kilometer per hour. Speed is also given in kilometer per hour, so no need to change in meter per second. Compare. So first of all things are given. Speed is given, radius is given. Then the AC is equal to V square upon R. We can calculate the centripetal acceleration and then divide with by acceleration due to gravity. Then we get the ratio of acceleration due to gravity, centripetal acceleration with acceleration due to gravity, that is AC upon G. This thing we have to find. So easily we can find very simple question. Look at the solution of the question. Here R is given 1 kilometer, that is equal to 1000 meter. V is equal to 900 kilometer per hour, which is equal to 900 into 900 kilometer per hour. You can direct, since we had converted to 900 into 1000 upon 60 into 60 meter per second, and it is equal to 250 meter per second. You can calculate it directly also, student. Centripetal acceleration, AC is equal to V square upon R. It means that 250 square upon 1000. And now AC upon G, which is equal to 250 square upon 1000 into 1 upon 9.8, which is equal to 6.38. So the value, the comparison, you can write it as AC is equal to 6.38 into acceleration due to gravity. This is very simple question. Directly you can calculate. Now the next question. Now look at the student. Look at here. The next question, and it is also a very simple question. First of all, we have to convert the length of the string, which is the radius of the circle. Suppose there is a string, and in this way we are rotating, so the length of the string will be the radius of the circle, horizontal circuit we are making. The constant speed, V is constant. If stone makes 14 revolution in 25 seconds, means from here number of revolutions, frequency you can calculate, that is number of revolutions upon the time taken to complete that revolution gives you the frequency. Then you have to find the magnitude and direction of acceleration of the stone. Magnitude and direction of the magnitude, that is centripetal acceleration, you have to calculate. So centripetal acceleration, that is equal to V square upon R, and here V is not given, angular velocity, we can calculate omega, that is equal to 2 pi f, and from that omega square into R. We had calculated a formula also, centripetal acceleration is equal to omega square upon R, and from here, from this we had calculated V square upon R, because omega V is equal to omega R, so V is equal to omega R. So putting the value of V is equal to omega R, we call V square upon R. So look at here, students, solution of this question. Here R is given, that is equal to 80 centimeter. 80 centimeter मतलब 80 upon 100 meter, that is equal to 0.8 meter. Radius it is given 0.8 meter, and frequency 14 upon 25 second inverse. Frequency 14 upon 25 second inverse. So we can calculate omega, that is angular frequency, which is equal to 2 pi f. We had calculated this formula, and from here 2 into 22 by 7 into 14 upon 25 radian per second. Radian per second. 7 to the 14, and it is equal to 88 upon 25 radian per second. 88 upon 25 radian per second. So centripetal acceleration, AC omega square R, and it can be written as 88 upon 25 whole square into 0.8, and it is equal to 9.90 meter per second square. This is equal to 9.90 meter per second square. This is the value of centripetal acceleration. And direction of centripetal acceleration is towards the center of the circle or circular loop. Whatever the circular path the stone is traveling along the center, it is the direction of centripetal acceleration, that is equal to AC, and the frequency we had calculated. So this is all about this question, students, and this is all about this video also, and this is all about this chapter also. We had discussed the whole chapter, that is chapter number 4, and now in the next video we will start the most interesting chapter, in which we will study about the forces, that is Newton's laws of motion. So that's all for today, students. Thank you, students. Have a nice day. Take care.